Hello my dear students, welcome to Computer Science class. Let us continue with our chapter, that is typical configuration of computer system. In our previous video class we have discussed what is computer and we have seen the block diagram of computer. Then we had discussed about how do we characterize the motherboard based upon form factor, chipset and the processor socket. And then we had started with the topic, the types of motherboard. Before we proceed, let us have a quick glance on what is motherboard. Motherboard is a large printed circuit board wherein it is having many chips, ports, controllers and other electronic components mounted on it. We refer the motherboard to be as one of the main circuit board within the computer system because it provides the platform for the different kinds of components and peripheral devices, the communication with each other. Say for an example, the electronic components could be like processor, memory chips, interfaces, various other different ports, expansion cards, hard drive, disk drive. So it will provide the communication between all these electronic components that are being mounted onto the motherboard. Therefore, the motherboard provides the platform for the communication with each other between these electronic components. Then we have discussed about the types of motherboard. Therein we have discussed about the XT motherboard. XT motherboard stands for extended technology. It is one of the oldest type of motherboard where it is consisting of low insertion force socket, that is LIF. It consists of DIM, that is dual inline memory module. It consists of the ISA, that is industry standard architecture slots wherein it is used for to connect the modem and the input devices, and it also consists of 12-pin power connector and it doesn't have any of the ports. Already I have discussed about this XT motherboard. So this is what is low insertion force socket, that is the processor socket, isn't it? And then dual inline memory module. As I discussed, it is having before we had single inline memory module, but the data transfer rate in case of dual inline memory module will be more comparatively to the single inline memory module. Next, today we shall discuss the next type of the motherboard, that is the AT motherboard. So this AT motherboard stands for advanced technology. So this AT motherboard consisting of PGA socket, that is pin grid array socket, and it consists of SDRAM, that is synchronous dynamic random access memory slot it consists of, and then it consists of 20-pin power connector. It consists of PCI slots, that is PCI stands for peripheral component interconnect slot, and it also consists of ISA slot, industry standard architecture slot. So therefore, let us see what is actually the pin grid array socket is. So this is the layout of the AT motherboard. Now this is where exactly we are having the pin grid array socket. Let me show you here. This is the pin grid array socket. So we have discussed the motherboard could be characterized based upon the processor socket, where it could be a rectangular processor socket or a square shaped processor socket, or it could be the PGA I was telling, that is pin grid array socket, isn't it? So this is one of the processor socket wherein the processor is being mounted into this particular socket. So here in this, actually this is where is the that is PGA socket is there. Into that the processor is located. Upon that the fan is being placed here. So to keep your processor cool, because enormous amount of heat will be generated. So in order to keep that processor cool, the fan is being mounted onto the processor socket. Alright. So that is what is the PGA array socket. Then as I said, it is consisting of SDRAM. So SDRAM, that stands for synchronous dynamic random access memory. So this is the SDRAM slot actually. Alright. So here the data transfer rate will be more comparatively to the dual inline memory module. Alright. And then we are having that is PCI slot. As I said, PCI stands for peripheral component interconnect. Mainly PCI is used to connect the graphics cards, sound cards. Okay, suppose if you want to play any video or audio file, if you want to play, then the sound card has to be present onto your motherboard. Those sound cards are actually being mounted. It has been placed in this particular PCI slot. Because of the presence of the sound cards, you are able to hear the voice signals through your speakers. Like that, similarly we have the ISA slot. As we know that ISA slots are used to connect the modems and the other input devices. Clear? And this AT motherboard, it is having the 20 pin power connector, as I said. So here you can see here the 20 pin power connector here. Okay, it is having the 20 pin power connector. Alright, so these are the few things that we can find it in the AT motherboard. So what are the examples for the AT motherboard is the Pentium 2 processors. Pentium 2 processors are the examples for the AT motherboard. Next we shall discuss the next type of the motherboard, that is baby AT motherboard. So here the baby mother AT board, so it is a combination of both the XT as well as the AT motherboard. Okay, so it is a combination of extended technology motherboard as well as advanced technology motherboard. So both it will be having the features of both the motherboard. So therefore this motherboard, baby AT motherboard, is having the slot type processor socket it is having, plus it is also having the PGA processor socket. It is having the slot type processor socket and it may have the PGA, that is pin grid array socket, plus it is also having the SDRAM, that is synchronous dynamic random access memory, which is actually belong to the AT. Apart from that, it is also having the double data rate random access memory slot also it is having. Okay, then it is having the PCI slot, the ISA slot, plus it is having the 12 pin power connector as well as 20 pin power connector, and it is having the ports. So ports it is having because to connect the external devices or any external peripheral devices to connect to your computer system. So baby AT motherboard provides the ports. Now let us see this. Examples are Pentium 3 and Pentium 4 are the examples for the baby AT motherboard. See, this is the layout of the baby AT motherboard. Now here you can see this is what is the processor socket, that is PGA. Okay, so this is a slot type processor socket we are having. Alright, and here is the pin grid array socket. It could be a slot type or a pin grid array sockets it can have. Then as I said, it is can have the SDRAM and double data random access memory. So these are the memory modules actually. This is SDRAM is been, how you can identify is it is having the 2 notches at the below. So this is the SDRAM, and you have, if you are having one notch like this, then it is double data rate random access memory. So this SDRAM is faster as comparatively to the dual inline memory module, but the data random access memory is the most fastest in case of the data transfer between the memory and the CPU. So let me make you to understand. I have got one image here. So here if you see, this is non-DDR in the sense that is synchronous dynamic random access memory. So synchronous dynamic random access memory will transfer the data between the that is between the memory unit and between the CPU only at the rising edge of the clock signal. Look at here. See, whenever the clock signals are high, the data transfer rate. Whenever the clock signal is low, no data transfer rate. Again, when the clock signal is high, the data transfer rate. So this non-DDR in the sense that is synchronous dynamic random access memory will transfer the data from the memory unit to the CPU only at the rising edge of the clock signals. Alright, it said, okay, whereas in case of double data rate random access memory, see, it sends the double amount of data in each clock signal. So how it is sending? Because it has the capability to send the data, to transfer the data between the memory unit and the CPU at both the rising edge as well as the falling edge of the clock signal. So at the both the time it is sending the data. Therefore, it will transfer the double amount of the data in each of the clock signal. So when the clock signal is high, in the sense it is clock signal is 1, the data transfer rate take place. When the clock signal is low, in the sense when the data transfer rate is, when the signal is low, then also data transfer takes place. So here non DDR will be transferring the data around 32-bit rate if it is transferring, the double data rate will transfer at a time for 64 bits at a time. It can transfer at the 64 bits of data it can transfer to the CPU at the one each clock signal. If at all, if it is 32 bits, if they are passing at each time, 32 bits means 30, that means per clock signal, if 32 bits are being transferred by the non-DDR, then 64 bits will be transferred by the double data rate random access memory. So therefore, the double data rate random access memory is considered to be as the most fastest random access memory that transfer the data between the memory and the CPU. So this baby 80 motherboard is having both the combination of SDRAM as well as the double data rate random access memory. Apart from this, it also consists of the PCI as well as the ISA slot. So as we know that the PCI and the ISA slots PCI are used to connect for the graphics card, sound card. Graphics cards, they are useful for the gaming purpose. Okay, they are also useful to connect the sound cards, whereas the ISA, we know that it is used to connect the modem, okay, and the other input devices. Now this baby 80 motherboard, it is consisting of both the 12 pin power connector and the 20 pin power connectors it is having. So you can see here, it is a 12 pin power connector over here, and it is also having the 20 pin power connector, and it was also having the external ports to connect for the peripheral external devices. So this is all about the baby 80 motherboard. Now let us discuss about the last type of motherboard, that is ATX motherboard. Yes. The ATX motherboard stands for Advanced Technology Extended. So these are the latest motherboard where the most of the computers are using nowadays. So it is consisting of MPGA processor socket, that is micro pin grid array processor socket it is consisting of. Now it is consisting of double data rate random access memory. I think now you got an idea. So the double data random access memory is a kind of a memory slot wherein it will help you to transfer the data both at the rising edge as well as the falling edge of the clock signals. And again we are having the PCI slots, and then we are having an extra slot known as AGP slot. So this AGP actually stands for Accelerated Graphic Port Card. Okay, so this is extensively provides you the faster access to the graphics accelerated card for helping for 3D gaming purpose. We have the PCI slots also that supports the graphics card, but it supports for the 2D games, whereas the AGP is quite expensive, and it is extensively and exclusively used for having the 3D game purpose. We are having the AGP slots. Alright, next we are having the IDE interfaces, that is primary and secondary IDE interfaces. So here IDE actually stands for Integrated Digital Electronic Port. So usually the IDE devices like CD-ROM, drives, hard disk drive are being connected to the motherboard through these actually IDE ports. External devices like CD, if you want to play CD in your computer system or any other external hard disk drive, okay, contents if you want to copy, then we have to make use of the IDE ports. So those all will be connected through this, that is Integrated Digital Electronic Ports. Alright, apart from this, it also consists of the SATA connectors. So herein I'll be showing you, this is how the ATX motherboards will look like. So it consists of as I said, it is MPGA, this is the micro pin grid array socket it consists of. Alright, then it also consists of the PCI slots and the AGP slots. Okay, here you can see the SATA connectors here. The SATA connectors actually stands for Serial Advanced Technology Attachment, that will help you to connect the hard disk drive and the DVD drives. Alright, so they are helpful to connect. See, you can see here the SATA connectors. So these are the SATA connectors that would help you to connect the hard disk as well as the DVD drives. Now here in case of the ATX motherboard, we have both the 20 pin and the 24 pin power connectors we are having, and this ATX motherboard is also having the ports into it. So here you can see the ports wherein it is helping to connect the external devices. Let me show you here the other images of the ATX. Here you can see this is the processor socket, right? This is CPU socket. So onto this actually we are mounting the fan. Okay, then this is the power connector we are having. This is the DRM slots. Okay, we are having, that is dynamic random access memory slot, and then this is the hard drive slots to connect. We are having north bridge here, north bridge and south bridge we shall discuss later. This is the ROM slots to have a memory slots. Here we are having, this is ROM slots. You can see here AGP, okay, accelerated graphic ports to have. This is the slot where those are the all like cards, they will be inserted into these ports. Alright, we are having the PCI slots, and these are, you can see all these are the different ports that is helping you to connect the external devices like, you know, USB flash drive, your speakers, okay, your mouse, your keyboard. They are all the external devices, right, for your desktop computers. Okay, laptop means inbuilt keyboards and all you are having. So this is how the, you know, we have the ATX motherboard. Here also you can see the clear picture of the ATX motherboard. So different versions have been there. Alright, you can see here the SATA connectors. Alright, so this is the CPU socket, external ports you are having. These are the memory slots we are having. Alright, next we are going to discuss about the components of motherboard. A very important question from this chapter. Explain any 5 components of the motherboard. The first component of the motherboard is the processor, next is the BIOS, next is the CMOS, okay, and then slots, disk controllers, input output ports and interfaces, then bus. BIOS actually stands for basic input output system, whereas CMOS actually stands for complementary metal oxide semiconductor. So in brief we shall discuss all these components of the motherboard. So herein first we shall discuss about the processor. See, the processor, as we already know, it is the main component of the motherboard, and usually we refer this CPU to be as the brain of the computer, because it is the only unit wherein it can read the instruction, it can interpret and it can execute the instruction. So as we know that the CPU consists of the ALU, right, the CU, as well as it also consists of certain set of registers. So this ALU actually would perform the arithmetic and logical operations onto the data, wherein the CU is responsible for organizing and processing of the data as well as the instructions. So therefore the control unit to be considered as it could control and coordinates the activity of the other units of the computer system. So we know that whenever the input data is being given to the computer, that input data first reaches to the memory unit, that is random access memory. From the random access memory, the instructions or the programs, okay, or the data is being passed on to the control unit. Control unit will see to that the entire instruction is being divided into series of logical steps, and then each of the instructions will be provided to the ALU to perform the calculation, isn't it? So CPU is the only unit that could read, interpret and execute the instruction systematically. So we considered it as to be the main part of the computer system. Whereas the CU, that is control unit, it will control and coordinate the other parts of the computer system. Means it controls the hardware components like input unit, the memory unit, the output unit, and it is also responsible to see to that the instructions are being stored systematically or not. So all these activities will be performed by the control unit. Then we have seen about the registers also. Registers within the CPU will be our temporary storage memory units they are, but they are very high speed memory units, but they have a very less storage capacity. They are available only within the particular CPU. Therefore, the registers are to be considered as the CPU's working memory units. Am I right? So, now let us understand what is this CPU is. CPU, if you are carefully observing, the CPU is actually being fabricated as a single integrated chip. Okay, the CPU, it has been fabricated with a silicon chip, that has been integrated chip. So we can also refer this one to be as the microprocessor. Okay, the CPU that is fabricated as a single integrated chip, we can refer it as a microprocessor. So this is a tiny chip where it contains the entire computations engine. So irrespective of whatever the calculations, whatever the operations you perform, you provide it to the CPU, it will process the data accordingly. So therefore it contains the entire computation engine. So this microprocessor is actually plugged into the motherboard into the CPU socket. So the company called as an Intel, it is one of the leading processor manufacturers in the entire world. Now, how do you get to know your computer system is very fast? Okay, how you get to know the system is very fast or it has become slow? How do you measure the performance of your computer system? So it is based upon the clock speed which is being mounted onto your motherboard. So the computer's operating system, it has actually been linked to the speed of the system clock actually. So therefore we can refer the clock speed of the computer system. The clock speed of a CPU is actually being defined as the frequency with which a processor executes the instructions or the data that has been processed. See, onto the motherboard we have the clocks. Okay, we have the clock signals. So based upon the clock speed, your computer is performing. Usually what is the performance of your computer? How do you measure the performance of your computer? That is based upon the clock's frequency. So the clock frequency is being measured in terms of MIPS, that stands for millions of cycles per second. Okay, and it is also measured in terms of BIPS, that is billion of cycles per second. So millions of cycles per second or billions of cycles per second or million instructions per second you can refer as, or billion instructions per second. See, within the motherboard we are having the clock. Alright, so based upon the speed of the clock signals, actually your CPU performance will be measured. So the unit what we are using is million instructions per second or the billion instructions per second. So usually we call it million instruction per second in terms of megahertz, and billion instructions per second we call it as a gigahertz we are referring to. Alright, so this is all about the processor we have discussed. So the other components we shall discuss in our next video class. Thank you students. Take care of yourself.